So, hello everyone. Today we are going to solve today's daily lead code problem. So, you can find that from here, the fire icon, the here. Let's see what problem is today. Today is problem number 1914, cyclically rotating a grid. Okay. So, what the problem statement says that you are given a m cross n integer matrix grid where m and n are both even integers and an integer k. The matrix is composed of several layers, which is shown in the below image, where each color is its own layer. Okay, so basically the matrix are divided into these circular layers. A cyclic rotation of the matrix is done by cyclically rotating each layer in the matrix. To cyclically rotate a layer once, each element in the layer will take place of the adjacent element in the counterclockwise. Okay, so basically, let's see here, blue is a layer and yellow is another layer. So in the blue layer, we have to rotate this with like, if we rotate once counterclockwise, the matrix will look like this. Similar with the yellow one. So let's see what we can do here. Like after reading the question, like proper simulation thing, we can just brute force simulate the process that we will retrieve the value layer by layer and then rotate the value here. We can do this here, or we can do like we will just traverse this, simulate this, and store the values in a vector, and then we will rotate the vector by k, and then we will reassign the values in the matrix. So that's the simple idea. So let's see what we can do. If we go to the one node, like let's see, this is a matrix. So we will first start from here, and then we will go to the right side, like until we reaches any end or any previously visited cell. Like we will go here, 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 and stop here because like after that there is no cell, and then we will go downwards. Like I'm just telling that how we will simulate the path. Like from starting from here, we have to retrieve this outer boundary. So then after that, we will just go here and then here. So we have to write the for loop, like first to go right, then down, then left, then up. And similarly, next we will start from here, and then we will also go from to the right until we reach any visited cell. Like we can't go further because this cell is visited means that is included in another, that is the part of another layer, so we can't go there. Then similarly we will go down, then left, and then up. So next we will start from here again, and then do this and this. So it's basic simulation. So in the code we will start from this top right corner, and then we will just go further, like we'll write for loops manually and then retrieve the value and rotate the vector and then reassign it. So it's like straightforward problem. So in the code, we will just take the values, like n is the grid size and m is the like number of columns. Now we will take, like we'll go diagonally, we go, and for we will go here. Uh, like to go diagonally, what we will do, we will just go 0 0, then 1 1, then like until we reach any visited cell. Like we will go first here, then here, then here, and then we will found the visited cell. So that means all the cycles are completed. So here, well, logically we can do like minimum of half of n by 2, or something like minimum of n by 2 comma m by 2. But if we like write simple m also, that will be That will also won't cause any problem because we will simply break once we find any visited path. So if we have visited like I comma I cell is already visited, that means that we have to just simply break, and otherwise we will rotate from I comma I. Rotate from means like this is the corner of that path and we will rotate this. So if I write the function, here I'm writing this in the lambda format, like you can search and learn about lambda functions in C++. Rotate from I j. Uh, and it will be a void, like return type will void. We will return nothing. We'll just, after doing operation, we will just assign the values. Now, what we need a visited array also. So, vector visited in vector bull in. Like normally we write the full data type here like this, vector bull this, but in modern C++, like after I think C++ 20, you can remove this. Like the compiler is smart enough to understand because we are writing this type here. And if we also don't want to write this, we have to just write here false so that the compiler will know that this vector is vector boolean type, and so that this vector will be a vector of vector boolean. So anyone will work. Let's keep it in this way. Now after rotate from, we will just first we will store all the values of the path. So we have the values, and we also store the index so that we can reassign the values. So index. Now we will just write four manual loops. First we will go towards right, then down, then left, then up. So like while we'll first take this, like current cell, we will take the values dot push back current value of the cell, that is grid of I comma j, and we will also push this index in the value. We will implicit back index dot implicit back, so I comma j. So what is the, like, many of you have used pushback, but what is the difference between pushback and implicit back? Like uh, implicit back do like create the object in place and push it in the backside, but pushback create the, like, make a copy of the object and then push it in the vector. Like if you want to push back this same thing, what you have to do, you have to write this I comma j, but you have to, if you look carefully, we are creating this as a pair. Like first we are creating this ij as a pair, and after that we are copying this and uh, we are pushing in the vector. But in the place back, what we are doing, we are not creating any pair, we are just passing the values, and the place back will create this in place and then will push it. So place back is a little bit faster than pushback if there is like any like non primitive data type are there. Like if I am pushing integer, then there will be no difference between implicit back and pushback because we are not creating any object like. So we are pushback, and we will also mark this current cell as a true because we already visited this. So let's reorder this. Uh, After that, we will just go right. So J will increase. So if the next cell is valid, means not out of bound, and it is not visited, I comma j plus 1, then what we will do, we will just increase j, we'll go to the next cell. That means the cell is the part of current cycle, and we will mark this cell as true, and also push this value indices dot place back I comma j, and value we will take the value push back grid of I comma j. So this is we are basically going right, like going right. Now we will just copy this. Now we'll go down. So while going down, we will change the I here. Now, sorry, this will be M, and here I plus 1 N, and this will be I plus 1 and J, and this will be I plus plus, and remaining will be the same. Similarly, now we will go towards the right, right. In the right, we will just decrease the J. So if J is greater than 0, and also I comma J minus 1 is a valid cell, then we will just simply do J minus minus, and the remaining will same, and we are going left here, and lastly we will go up. So while going up, we will just check if I is greater than 0 and I minus 1 comma j is a valid cell. Then we will just simply reduce this, and we'll take the value and also store the index. So that's looks good to me. Uh, let's minimize these four manual loops. And after that, we will just rotate this, like rotate this values vector by k. And then we will just reassign this. So for reassign this, we will again take this indices, and also take a pointer here, pointer 0, and we will reassign the values that grid of x comma y equal to values of pointer plus plus. So that is good, I think. What we have to write, we have to write this rotate function. So this rotate was vector in ampersand v comma in this k. Uh, and lastly, we will return the grid because we are rotating this grid in place. Everything looks good. Let's minimize this function also. So we have to just rotate the value vector by k position towards the left side. So like while rotating, we have to just if we see carefully in the question, like k can go up to 10 to the power 9. So if I want to do k rotation one by one, it will give us time limit exceeded because we can't do 10 to the power 9 times to a like n size vector or something. So what we can do, we can just reduce the size, because we all know that if a size of a vector is n and we make rotation n times, the vector will be the same as the original. So we will just modulo the k uh, with v dot size, so that we can know that how many extra rotation we need to do after all of this. And then you can do it manually or use a HTL function like rotate v comma v dot begin plus k. So many of you can like be interested like what is this ranges. Like ranges is a library included in modern like C++ after C++ 20 that handles the container which and the standard algorithms with the ranges. Like if I use only rotate function call, which is standard rotate, we have to write this in this format. Like we have to give the start of the container, then the middle point, like from where we need to rotate this, comma, like we rotate, kind of this. But like this is standard included in standard library, like std rotate. But this is like std ranges rotate, so we don't have to put the start and end of the container. We can just pass it, and then we have to give the rotate point, like from where we want to rotate this. So we're not using std wall, std means. So I think that should work. So what we are doing here, we are just going it diagonally, and if that is the diagonal cell is visited, then we will break because no more cycle is left. That means, and then we will rotate from that point. And what is rotate from function doing? Taking that particular cell and then going like we are simulating a full cycle rotation, and then we are taking extracting the values and the indices, and after that we are just rotating the vector and then reassign the values to the corresponding indices. So let's run this on the samples to check everything is fine or not. So we get error. So I made a typo here, think. So it should work. Yeah, it got AC on the samples. Let's run this on the main test case to check if everything good or not. Yeah, it got accepted. So the idea is simple. We have to just straightforward simulate this, and you will like if you do like solve a daily problem, you will get a coin. So with this coin, you can purchase goodies like t-shirt, hoodies, and diaries, other things from here. So solve this. If I try to understand the time complexity here, so the time complexity is like uh, here we are going like at most going n by 2, minimum of n by 2 comma n by 2, uh, which is order of n or m here. And here we are like if you see of like overall we are covering all the grid once. So the time complexity will be n cross m. And here we are rotating this. So rotating will take like k times. But here we are like modulo this k with the size. So it will also stay under the n cross m limit. So the time complexity will be overall time complexity is order of n cross m, and similar the space complexity will be like we are using these things. Uh, we are extracting the values and doing the same thing. So it is kind of this length of the cycle, which is also similar to like order of n cross n. So that's all for today. Like let me know in the comment if you have used any other approach. Like you can use a math, little bit of math here without using this visited array. You can just go up to n by 2 and m by 2, and then you can figure out like a current cell, like the current cell is part of which layer, and then do the basically same thing. So you can reduce this space here, like this visited, but you have to use then a little bit of mathematics. But otherwise, here we are using simple idea that without any mathematics knowledge or something, we are just simulating and marking the path which we already covered. So that's all for today. Thank you.